Hi boys and girls, your 3/4 module assessment's coming up. Let's review. We are going to multiply or divide and draw a model to explain our thinking. We have 1/2 times 1/3. Well, 1/2 looks like this, and 1/3 looks like this. Well, 1/2 times 1/3 is what's shaded by both, which is 1 out of 6. So 1/2 times 1/3 is equal to 1/6. 3/4 of 1/2. So again, we have 1/2, and we want 3/4 of it. So we're going to split it into fourths. We're going to shade 3/4. Our answer is what is shaded by both. We have 3 shaded by both out of 1, 2, 3, 4, 5, 6, 7, 8. So our answer, 3/4 of 1/2, is 3/8. Now, in order to do C, we have to do one of two different things. We either have to multiply the whole number times the fraction, and then the fraction times the fraction, and add them together. So let's do that first. 2 times 7/9 is 14/9, and 3/4 times 7/9 is 21/36. Now we have to change to common denominators, so we need to change 14/9 to a common denominator by multiplying by 4/4. 14 times 4 is 56/36. So we have 56/36 plus 21/36. And 56 plus 21 is 77/36. So now we have to do 77 divided by 36. 36, let's see, 36 times 2. 2 times 3 is 6, plus 1 is 7. So 2 would be 72, and we've got 5/36 left. Okay, so we've got 2 and 5/36. Now, the other way we could do this, let me erase some of my work over here. The other way we could have done this is we could have changed 2 and 3/4 to an improper fraction. So 2 times 4 is 8, and 8 plus 3, what I did denominator times whole number, 2 times 4 is 8, and 8 plus 3 is 11. I have 11/4 times 7/9. 11 times 7 is 77. 9 times 4 is 36. And we've already changed 77/36 to our mixed number, so our answer is 2 and 5/36. So remember, when choosing these, you could choose either to do the whole number times the fraction and the fraction times the fraction and add them together, which was the first way I showed, or you can change to an improper fraction and do the second way that I showed. Now we need to multiply or divide using any method. We have 1 2/10 times 31. Well, because it's written as decimals, I'm just going to multiply as decimals. I know I have to multiply by 10 to move that decimal out of the way. Now I can multiply as normal. 1 times 2 is 2, 1 times 1 is 1. Placeholder, 3 times 2 is 6, 3 times 1 is 3. Add my partial products, and I get 372. Because I multiplied by 10, I have to divide by 10 or do the inverse operation. Move my decimal in one place, divide by 10, and I get 37 2/10. So A is equal to 37 2/10. For B, I'm going to do the same thing. I have 1 2/10 times 31/100. I'm going to not put this 0 down because that's just one more place that I have to do, but it has no value. So I don't need it. I have 1 2/10, I have to multiply it by 10 to make it a whole number. 31/100, I have to multiply it by 100 to make it a whole number. Now I can multiply it as normal. 1 times 2 is 2, 1 times 1 is 1. Placeholder, 3 times 2 is 6, 3 times 1 is 3. Add my partial products. Now, because I multiplied by 10 here and 100 here, I have to divide by 10 times 100, which is 1,000. So I have to divide 10, 100, 1,000. The answer is 372 thousandths. Now I have 12 6/10 times 3/5. Well, I could either change 3/5 to a decimal or 12 6/10 to a fraction. The only reason I'm going to do it as a fraction this time is because I've done the last two problems as decimals. If you decided to do it as decimals, that's totally fine. It would be equivalent. So I have 12 6/10. I need to write that as a fraction since I'm doing fractions. So 12 6/10, or 12 6/10, times 3/5. Now remember, when I do this, I have to do the whole number times the fraction, and then the fraction times the fraction, and then I have to add them together. So 12 times 3/5 would be 12 times 3/5. And 6/10 times 3/5 is 6 times 3/10 times 5. So now I have to do both of these problems and then add them together. So 12 times 3 is 36, so I have 36/5, plus 6 times 3 is 18, and 10 times 5 is 50. So I have 36/5 plus 18/50. Well, I can't add those together because they don't have the same denominator. But I know I can change 5 to 50 if I multiply by 10. So I'm going to multiply by 10 over 10, and I'm going to get 360 over 50 plus 18 over 50. And now I'm going to add them together. Sorry, I'm running out of space, so I'm going to end up putting it up here. I have 360 plus 18. Sorry, I'm getting messy now here too. I have 378 over 50. Now if I divide 378 by 50, I'm going to get my answer. I'm going to try 50 times 7 and see how close to 378 I get. 7 times 5 is 35, times 10 is 350. That's pretty close, because if I went 50 times 8, it ended up being 400. So I've got 7, 350, and now I subtract, and I get 28/50 left. So my answer is 7 28/50. For those of you that did this as decimals, all I have to do is change 50 to 100. And I know in order to change 50 to 100, I have to multiply it by 2. And 28 times 2 is going to be my numerator, which is 56. So 7 56/100, 7.56. So anything that's equivalent to 7 56/100 or 7 28 over 50 is correct. Let's move on. Robert claims that multiplication always makes a number bigger. He gave the following examples. If I take 6 and multiply it by 5, I get 30, which is bigger than 6. So he said 6 times 5 equals 30. And 30 is bigger than 6. If I take 1/3 and I multiply it by 2, I get 2/3, which is bigger than 1/3. 1/3 times 2 equals 2/3, and 2/3 is bigger or greater than 1/3. Robert's reasoning is incorrect. Give an example that proves he is wrong and explain his mistake using pictures, words, or numbers. So, he did provide 2 examples when the number gets larger, but multiplication can sometimes get smaller. For example, if we multiply a fraction times a fraction, 1/3 times 1/2 is 1/6, and 1/6 is less than 1/3. Or if we did 1/8 times 1/3, that equals 1/24, and 1/24 is less than 1/8. So what's happening is when we multiply by a fraction by a fraction, we're getting a smaller number because we're multiplying by a number that's less than 1. So this is why Robert's reasoning is incorrect. Now, this problem, you actually don't need to solve, but I want you to find some errors in this problem. So we are not going to solve part A here, but it says McKenna's collecting milk from 8 different cows and recorded the amount collected in gallons from each cow in the line plot shown. What is this line plot missing? If you said the title and the label, you are correct. On your assessment, you will be seeing a line plot, so you need to make sure that you understand that each line plot looks like this, but also has a title and a label. Go ahead and title and label this if you haven't done so already, and then come back and I will tell you what it should be titled and labeled. It should be labeled gallons because the milk is in gallons, and the title should say milk collected, okay, which is what it's showing. This next problem says that Zoe had 2 3/4 pounds of butter. She used 4/5 of it for baking. How much butter did she use baking? So she had 2 3/4 pounds and she used 4/5 of it for baking. She used 4/5 of 2 3/4. They want to know how much did she use for baking. So we need to do 4/5 times 2 3/4. So we could do this two different ways. We could multiply the fraction times the whole number and the fraction times the fraction and add them together, or we could change to an improper fraction. So I'm going to do that way since we did this way in a problem previously. If you did this way, they will end up with the same answer. So I'm going to change 2 3/4 to an improper fraction. I know that 4 times 2 is 8. 8 plus 3 is 11. So that's equal to or equivalent to 11/4. And I need to do 4/5 times 11/4. 4 times 11 is 44. 5 times 4 is 20. And 44 divided by 20, I know it's going to be 2 because 2 times 20 is 40. And 4/20. So the answer is 2 4/20. Or it could be equivalent. If I divide both of these by 4, I know I get 2 1/5. So if you had 2 4/20, or 2 2/10, or 2 1/5, you are correct. Josie had a half-gallon of lemonade. She sold 3/4 of it. How much lemonade in cups was sold? So I'm going to draw to show that this is what she had. Okay. She sold 3/4 of it. So I'm going to split it into fourths. Okay. This is what she sold. So I have to do 1/2. So 3/4 of 1/2, or 1/2 times 3/4, or 3/4 times 1/2, is 3/8. Now, 3/8 is a gallon, and they want to know how many cups was sold, so we need to change this to cups. So we need to know how many cups are in a gallon. And looking at our reference sheet, we know that there are 16 cups in a gallon. So we need to multiply by 16 to get our answer. So we're doing 3 times 16 over 8. And I know that 8 and 16 can both be divided by 8, so I'm going to simplify first. And 3 times 2 is 6 over 1, which is equivalent to 6. So there were 6 cups of lemonade sold. This video was to prepare you for your upcoming assessment. If you need more practice, have somebody make up some questions for you so that you can practice these skills. Thanks for watching.